Here it's useful to remember what HK notation actually is. If you have a quadratic function, f of x is, in this case, we have ax squared plus bx plus c. In HK notation, this is going to look like a times x minus h quantity squared plus k. And then if I have this, I can read off the coordinates of the vertex. The vertex would be at h comma k. So looking at what HK notation is, to get there, what I want to recognize is that I'm going to have a perfect square of a binomial, and in particular, it's going to be 1x minus h. So that tells me if I'm starting off with this particular quadratic function, 3x squared minus 12x plus 1, I'm going to need to complete the square, and I want to have 1x when I do that. So to start with, I'm going to factor a 3 out of my first two terms. I'll have 3 times x squared minus 4x. I'm going to leave a little bit of space here for my completing the square work. And then I just have to figure out what goes in here to make everything work out. When you complete the square, if you have 1x squared, take a look at the coefficient of x and divide it by 2. This will give me negative 2. Square that value. That's equal to 4. And then I will add and subtract that value in the same place. So I'll add it and I'll subtract it. Effectively what that means is I'm adding 0, so I'm not changing the value of anything, but I'm now going to have a perfect square. To see the perfect square, erased too much there. To see the perfect square, if I look at the first 3 terms, x squared minus 4x plus 4 factors to x minus 2 quantity squared. I still have this minus 4 over here that I'm going to bring down into plus 1. My HK notation doesn't allow me to have these brackets with extra stuff in it, so I'm going to distribute the 3. I'll get 3 x minus 2 squared. 3 times negative 4 is negative 12. Bring down the plus 1. And then combine my like terms. 3 x minus 2 quantity squared minus 11. If I compare this to the standard form for HK notation, a x minus h squared plus k, I can see that h must be 2, k must equal negative 11, and then the vertex is always at hk, so it is at 2, negative 11.